So in this video we're going to talk a little bit about angles and radians and how you convert back and forth between degrees and radians. And you may remember from previous lessons that a radian is defined as the measure of a central angle whose intercepted arc is equal to the radius. So what that means that if we take this radius here, this radius r, and we wrap it around the circle, it's going to create an angle that measures exactly 1 radian. So this angle here is measured to be exactly 1 radian because the radius is equal to that arc right there, CB. And if we keep rotating that radius around the circle till we get to half a circle, that's going to be exactly 1 pi radians. And if we go through the full circle, 360 degrees, that's going to be equal to 2 pi radians. And that's because the radius will fit around the circle exactly 2 pi times. The circumference is equal to 2 pi times the radius. So, how does this help us? This means that when we're dealing with radians, if we want to convert back and forth, all we have to really do is remember the ratio that 180 degrees is equal to pi radians. This is the key scale factor for us, so that anytime that we want to convert back and forth, this is the ratio that we have to remember. So if we had something like 60 degrees and we want to know, well, how many radians is that going to equal? All we're going to do is set up a proportion. It's going to be always into the proportion compared to 180 degrees. So we're going to use degrees over radians is equal to 180 degrees over pi radians. So for this one over here, it's going to be 60 degrees over x radians is equal to 180 degrees over pi radians. And as we cross multiply, we're going to get 180x equals 60 pi. And if we divide by 180, we're going to get x is equal to pi over 3 radians. If we wanted to go the other direction and convert from radians back to degrees, we can use the exact same method. So let's pretend that we had pi over 2 radians, and we want to know, well, how many degrees is that going to be? We're going to use the same proportion. So that's just going to be x degrees over pi over 2 radians is equal to 180 degrees over pi radians. And as we cross multiply, we're going to get pi x is equal to, and then 180 times pi over 2 is going to be 90 pi. And if we divide both sides by pi, the pi's will cancel. So we're just going to get x is equal to 90 degrees. All right, so here we can see that 60 degrees was equal to pi over 3 radians, and that pi over 2 radians was equal to 90 degrees. And if you know anything about the unit circle and you can remember some of the points that are on it, those probably look somewhat familiar to you. Okay. Remember that when we have a circle, if we draw a circle here centered at the origin, everything on this circle can be related back to degrees and radians. So let's say we have an angle in what's called standard position where one side of the angle is right there on the x-axis. And we're going to draw a second part of the angle over here. Okay? And so we'll say that this angle measure here, this is going to be theta. Now theta always represents the number of radians or the number of degrees inside of that angle. We'll call the arc length, which I'm going to highlight over here in yellow. This arc length here we'll call S. So if I want to know how many radians are inside that arc length, or inside that angle rather, all I'm going to do is take my radius and divide that into my arc length. So theta, the number of radians, will equal the arc length divided by the radius. Okay, so however many times my radius fits into that arc, that's how many radians will be in that angle. And if I then want to go from the number of radians to the number of degrees, I can just come back over here and use this little formula for us. So that's where radians and degrees come from. That's how you convert back and forth between them. That's how you can go from an arc length into radians or an arc length into degrees. And I hope this helped, and I'll see you in the next video.